My name is Michael Janik. I'm a professor of chemical engineering here at Penn State. Chemical engineering combines mathematics with chemistry, biology, and physics to solve some of society's most pressing issues in human health, food supply, environmental sustainability, and energy. Chemical engineering students complete coursework in areas such as organic chemistry, thermodynamics, advanced mathematics, and chemical process design. Chemical engineers are employed in a wide array of enterprises, such as the pharmaceutical, chemical, and biotechnology industries, semiconductor manufacturing, energy production, government organizations, and environmental companies. Penn State Chemical Engineering graduates work in process engineering, product development, technical sales, environmental control, safety, and research and development roles. Many go on to graduate or professional schools for further education. Penn State's Department of Chemical Engineering is housed in the new Chemical and Biomedical Engineering building, featuring 109,000 square feet of state-of-the-art lab space, classrooms, and a variety of collaborative learning spaces for students. Most students end up in chemical engineering because of their broad interest in science and math and their desire to work on an application. So chemical engineering requires more basic sciences than the other engineering majors. We require chemistry, physics, and biology classes. So chemical engineering tends to attract students with a broad set of interests, but of course especially with an interest in chemistry and then translating that to application.
I chose chemical engineering as my field of study because I wanted to make an impact on the world. Having researched a little bit about chemical engineering as an undergrad, I found that things like environmental protection, lightweighting, and using chemistry to better the world was something I was really interested in.
I think a good indicator that you would be well suited for chemical engineering is being curious about how processes work. A lot of chemical engineering really stems from process engineering and understanding how to maximize, optimize.
I would say chemical engineering is both theoretical and hands-on. We deal a lot with theory, but then we actually have ways and learn ways in which we can actually apply that.
We have our chemical engineering lab that we take, which focuses on 4 different aspects of chemical engineering. But it's very different than sitting in a lecture hall and just kind of hearing how these things work. It's really, really beneficial to actually see it happening.
Chemical engineering is probably more versatile than you would think. I used to imagine that it was going to be all chemicals and research all the time. But because it's engineering, you can really choose which side of that you want to be on. You can be more towards the engineering side and do more process engineering and work with how they're made and developed. Or you could go into more of the science field and the science part of this and work more with the development of new types of chemicals.
There are definitely research opportunities for chemical engineering undergrads. We have research labs that deal with polymers. We have research labs that deal with electrochemistry, fracking, natural gas, even algae and biofuels.
Some of the research opportunities that I was involved in were water purification. I also do research in cosmetics, specifically lipsticks. I never thought I would see myself doing something so different and outside of my comfort zone, especially because I had no background. But it's really interesting that chemical engineering has given me that opportunity.
Some of the developing initiatives in the chemical engineering world are really around our carbon footprint and the environment and impacting society as a whole. So some of the projects, for example, that I work on are related to lightweighting, trying to reduce fuel consumption, environmental resource protection, and how can we decrease our use of resources that we have as a limited supply on the earth while we're here.
So one of the things that I love about chemical engineering is that you get to work for places that make a big difference in the world.
I think the world is heavily integrated with chemistry, and I think if you have that strength and you have that strong background, and then you pair it with a chemical engineering degree that teaches you troubleshooting and problem solving, and can teach you how to bring a team together and go out and solve those problems, I think that no matter what you end up doing, you can be successful at it.
The field of chemical engineering builds on science and math to apply to many different problems, and that attracts students that are interested in important problems that can impact our society. And our very talented students become problem solvers, and it's quite exciting to work with a group of students eager to solve important problems.